Let's look at this last problem in this AMC8 test. In the figure shown, this figure, we have the line segment US and the UT are line segments, each of length 2. Okay, so this is of length 2 and of length 2. And the angle TUS, that's this angle, is 60 degrees. And arcs TR and SR are each 1/6 of a circle with radius 2. And the question is, what is the area of the region shown? Alright, so there are many numbers in this problem. So what draw my attention most is the degrees. So we have 60 degree, good. And the arcs are each of 1/6 of a circle. What does that mean? So we know that if we have a full circle, right? So 1/6 of a circle. So the central angle of a full circle, that's 360 degree. And the 1/6 of a circle, so that got to be 60 degrees. Does this number sound familiar? We have a 60 here, and we have 160, actually two 60s here. One for arc TR, this arc, and the one for this arc TSR. All right, does that remind you of something? Does that remind you of anything? I think yes, a equilateral triangle, right? So for equilateral triangle, all angles are of 60 degrees, right? Each of them. So if we extend this line segment here, right? And basically we are completing this these arcs as well. It's not these arcs, but these fan-like shapes. So, and then we connect this. Do you see that? So if this is the center of this angle for arc SR, right? So this is 60 degree. And the same thing for this one. That's 60 degree, right? So now let's say this point is, let's say this vertex is A and this vertex is B. So we fulfill an equilateral triangle, and we have 60 degrees on the top and two bottom 60 degrees angles. Beautiful. And at the same time, let's double check that. We have this radius of 2 and 2 and 2 and 2. So let's see, this 1/6 of a circle with radius 2. Do you see that? Good. So as long as we have this one, then the rest of the work will be easy. So basically, this area is the full area of this equilateral triangle minus the area of these two 1/6 of a circle. So let's look at the area of this triangle. For equilateral triangle, and with a side length of what? Of 4. Is it? Because we have the 2 here, 2 here, right? We add them up. 2 here, 2 here, and 2 here, and 2 here. We add them up. That's 4. So let's calculate the height of this triangle. Actually, there is a formula for that. If you got a good memory, you can use that formula. But just in case you forgot it, let's derive that formula. So we know that this is 4, and this base is bisected by this height, right? So that's 2 and 2. Let's remove this 4. All right, and then this is 60 degrees. No, that's a 30 degrees. Actually, that doesn't matter. You can use trigonometry to do the calculation, but let's just use the Pythagorean formula. So, the height will just equal to square root of 4 square minus 2 square. And that is 16 minus 4. That equals to square root of 12, and that equals to 2 times square root of 3. So the area of this triangle, this equilateral triangle, will be 1/2 times the base, length of the base, that's 4, times the height, 2 times square root 3. So that'll equal to what? Equals to, we cancel out these two, so that's 4 times square root 3. All right, and we need to subtract the area of these 2 1/6 of a circle. All right, then what is the area for a full circle with radius 2? For a full circle, the area will be pi times r squared, that's 2 squared, so that's 4 pi, right? And then we have 2 1/6 of circle. So basically that's, we add them up, that's 1/3 of a circle. So that'll be a third of this number. All right, so the area of the this area, this question area, that'll be this number, the area of this triangle, minus 1/3 of a full area of a full circle. So that's 4 pi. So let's collect the terms. Actually, nothing to collect. Let's just simplify that, rewrite this in an easier to read format. So that minus 4/3 times pi. So that'll be our answer. 4 times square root 3, and then minus 4/3 times pi. That's this, right? So B is our choice. If you like this video, please subscribe and thumb up. If you have questions, please comment.